Hi, good afternoon. My name is Derek Range. I did start the recording. This session is with Matthew Bucket, and we're going to be going over Sakai deployment with Docker. Matthew is a senior VLE developer for the University of Oxford, and he's also a Sakai team member. So, Matthew, if you want to go ahead and get started with the session.
That's great. Thanks a lot, Derek. All right, welcome to Sakai with Docker. So this is a sort of a basic introduction to Docker and how we've ended up using Docker with Sakai here at Oxford in our deployments and our development setup. So I'm sort of the lead developer locally at Oxford on our service. Locally we call Sakai WebLearn. So if I accidentally say WebLearn, just translate it to Sakai. And one important thing about our deployment here at Oxford is that we have a separate team that is responsible for the hosting, and that's completely separate from us. It's a team who develop the actual software, so there's quite a division of responsibilities. So let's start off. What is Docker? So there's a nice snippet from the Docker website about what Docker is. An open source project to pack, ship, and run any application as a lightweight container. If you're reasonably experienced of doing software, effectively Docker is a way of running a process, so a single process, in an isolated environment. And that's all it really is. It's a way of taking something you'd normally run on a server with loads of other stuff running in the background and isolating it so that you've got a reproducible entity that you can run anywhere. And you're more explicit about exactly what it depends on and what it needs to run. One thing about Docker is that it, at the moment, really is Linux only. So to run a Docker container, you need a Linux machine. And slightly confusingly, Docker is lots of things as well. Docker is a company. It's a client command line tool, and it's also a daemon. So they call three things the same word, Docker, which sometimes makes it a little confusing what people are talking about. What's this sort of for? So it's all very well isolating your programs, but it's quite nice to be able to know that your application is going to start up in a particular environment. Being able to quickly take your application and put it on a machine and start it up and not have any problems where you haven't remembered to install some extra libraries. Because it makes it fast, it makes it easy to scale outwards. So you can easily take an application, well, as long as the application's architected correctly, from a deployment point of view, it should be reasonably easy to take an application that you've got on one machine and deploy it to 3 machines and then more. And yeah, and there's some buzzword about density. Whoa. So yeah, what does it do? It basically isolates a process in its own environment so that it's not exposed to anything else, and it has its own file system to mess with. So that if you've ever heard of Solaris zones or BSD jails, it's sort of very similar to those. It's nothing really clever. It's just built on top of standard technologies that are available inside Linux. So it doesn't have any weird kernel modules. It uses features that are already available in the Linux kernel and wraps them all up with a nice front-end tool. So it uses namespaces, both process IDs and now of UIDs in the latest release. And it also uses C groups for isolating. What was the C groups bit? Sorry, I forget that. But it also, to support its use of, or efficient use of running It uses copy on write file systems very heavily, so that you can easily have images that you can revert back to. So it's also very much aimed at being able to know that the next time you start up your process, it will be starting up with exactly the same file system. And to do that, it uses copy on write file systems. So that means that it's quite easy to throw away the changes that you might get on a local file system. So for example, in the case of Sakai, you can have it. If you normally bundle up all of your Sakai application to create a whole load of wars in the Tomcat Web Apps folder, and then at startup Tomcat unpacks them, you can have it that Docker, every time it starts, it redoes the unpacking. That's not necessary. I'm not saying you necessarily want that, but that ability of throwing away changes from a previous run of the program is very possible with Docker and almost encouraged. So what sort of makes up Docker? So Docker's sort of got four major, well, it's got lots more parts now, but at the very basic level, it's got an image, which is a layered file system. So if you think you might, every time, and all of the file systems in Docker are, I say read only here, but it's better to think of append only. So you might start off with a standard Debian image, a standard Debian file system, and you can't change that file system, but you can layer on top of it another file system that contains some changes. So say you wanted to install Java into a Docker image, you would take the standard Debian image and then layer on top of it a file system that contains the changes that are needed for the JDK to be present in that image. And so then it's very easy to just go back and forth between an image with the JDK or the plain Debian image. And this also leads to how you end up with very efficient reuse. If you base all of your images on a standard base image, so say you have one base Debian image, and then in one of them you install MySQL, and in another base image you install, sorry, in one base image, in one copy you take the base image and then install MySQL on top of it, and then in another image you take the standard base image and install Tomcat and Java on top of it, you still only have one copy of the base image on disk. Now this does mean that the file system I/O isn't quite as fast, but for all intents and purposes it's plenty fast enough in most applications. So that's how Docker deals with images and sort of builds its file systems. Docker has this concept of a container, and a container is basically an image with all of its layers and a process that you're going to run in that image. And so the process could be something as simple as bash, it could be something as complex as Sakai that you're going to run, and it's containers that you start and you stop and you kill. Okay, so you never run an image, as it were, you always run a container. So a container is closer to a process. By default, Docker isolates all of the networking. So when you run a Docker container, you'll get your own private network. And by default, the only things that will be exposed will be the ports that you've explicitly defined. So you'll say I want to expose, say, port 8080, and it will just be that single port that gets mapped out to the actual machine. And I'll skip file systems for now. Docker also allows you to mount in normal file systems, but it's easier to skip that for. So that's a bit about what makes up Docker, but what are some actual sort of use cases why might you want to do this? Well, it's really good for reproducible builds. When you're starting with exactly the same base image, it makes it very difficult to break your build because you are missing some particular library or dependency. For us in the Java and Maven world, that's not quite as important, But if you're dealing in other languages such as Python or Ruby, where you tend to install more packages manually, and they might have greater dependencies on operating system libraries, that can be a real benefit, that you know you're compiling against exactly the same version of libevent, for example, in all of your builds. And along with that, it means you can use exactly the same build for development and production. So previously here at Oxford, we would develop, or I personally develop on a Mac, so I would build on a Mac and run on a Mac. But our production environment was purely Linux. And so I was never quite testing exactly the same setup. And again, it's not quite as bad in the Java world because you get an awful lot of isolation with the JVM. But we did hit quite a few production bugs because of the environment. So one example was fonts. The JVM on Linux depends on some operating system installed fonts. And so we had some weird issues where those fonts were available on my Mac, but in production, and they're available actually on our staging server, but we'd recently upgraded our live environment and the fonts weren't there, so some of our PDF rendering failed. With Docker, because you're providing the complete file system, you can test exactly the same build on my Mac that's going to run in production, so you can completely eliminate those sorts of errors. It also makes it easy to test without lots of machines. So Docker allows you to, one, to test on different OS base images, but also to run multiple Docker images locally without a large overhead. Unlike virtual machines, it's a much lighter weight way of isolating processes, and so it's quite easy to run several copies of, or several Docker containers at the same time, or hundreds if they're small. And for us, this was a real benefit, was defining a nice boundary between the developers and the hosting team. So now, it used to be that our hosting team was responsible for taking our, what was a big tar.gz file, and deploying it on a server, and then starting up the JVM with the correct arguments, and making sure the config's in the right place, and so on. Now, in effect, all they have to do is run the Docker container. They do still have a tiny bit of config, things like the database passwords and that sort of stuff, but we have a really nice boundary. They just take a Docker image and run it, and don't really care too much what's inside it. We're much more in control of the processes that get started up and the arguments that they're given, and we can have the same setup on both things. It's really good about keeping your deployments isolated, so it's quite an effort in, well, it's not quite an effort, you have to be explicit, and this sort of ties in with the next point about what you're going to depend on, what you need, and what you're going to provide. And you can't end up accidentally, it's very hard to end up accidentally depending on something and not realizing it, because you're much more explicit about all of the steps that you need to build an image. Okay, so I've been talking about these images, and it's what Docker starts off with for creating a file system. And to create an image, you can basically do it several ways. There's pre-created ones that are on the Docker Hub, and Docker will automatically download from there. You can create something called a Docker file, which is instructions for how to create a Docker image. And normally that will build on top of an image that is available in the Docker Hub. You can import a image. So if you've got an existing zip file that you want to be the basis of your image, you can import that into Docker. But one thing is to try and keep it simple and small. These images get sent over the network and are copied around. So there's every time you add an extra 500 meg to the image, you make it harder to copy around quickly, and yeah, it just makes it more intensive. So there's a real benefit to try and keeping everything small. And so if you're doing production deployments, this compared to something like VMs for providing that, or virtual machines can provide lots of those sorts of features in a similar manner. Well, not in a similar manner. There's similar benefits, but Docker is much more lightweight. Rather than having a whole kernel and operating system, all you have is a file system image and a process running. So you don't have as much of the security overhead or the startup overhead. It only deals with Linux, so you're not as flexible. If you want to run Microsoft IIS, you can't do that with Docker at the moment, I believe. It's less secure, so VMs typically are nicely isolated from each other, and if VM gets compromised, other VMs on the same host should be reasonably secure, unless you have bugs in your virtualization. But you've got a good layer of security. Docker does provide some of that, but it's less. Yeah, there's much less emphasis on security being a reason for doing it. And it's quite important. Docker facilitates you to use it differently to how you might use a VM, just because of its pure speed. And yeah, as I said, resource constraints aren't a primary focus. So I'll come to the question later. Okay, so if you're interested in Docker and aren't running on Linux, there's a solution for that. So Docker provides you with, or can provide you with, something called the Docker Toolbox. It was previously called Boot to Docker, and it's also known as Docker. Well, Docker Machine is part of the Docker Toolbox, and it allows you to run Docker on Windows and Mac. You don't need any of the Docker the Boot to Docker stuff on Linux because you can run it natively. So if you can see my terminal, I'm on a. Does that tell you? There we go. I'm on a Mac, but what Docker Machine and the Docker Toolbox do is mean that it looks like I have a native Docker command. So here we go. Let's start this off. So there's two commands. There's Docker, which is the low-level command for manipulating Docker images and containers, and there's Docker Machine, which is the command for manipulating machines running Docker. And because I can't run Docker locally on my Mac, I have to use Docker Machine. So Docker Machine allows you to see all the machines that you have available to you. So here I've got two machines. I've got one running on AWS, Amazon Web Services, and one running locally inside VirtualBox. So now I can set one of them to be active. So what this does is basically set some environmental variables. It's a little shortcut to set some environmental variables to say I want to be using the dev machine, which is the one running locally. So if I rerun the Docker Machine ls, you can now see I've said make dev machine active. And now if I type docker ps, this will list all of the containers that I have running in that VirtualBox instance. And at the moment I've got nothing running. Let's give you a quick example. So if I want to run something, let's run let's see if I can manage some commands. So this will run a new container. It will run the Ubuntu image version 14.0.4, and I want to run the bash command in that container. The -it is needed because it's an interactive one. And this is going to run it locally on my dev machine or on my VirtualBox Linux VM. So there we go, it started a new container, and I've got a shell prompt in this container. and I'm completely isolated here. So if I do PSAUX to show the processes that are running, it just shows you the stuff inside the container. And if I log out, I'm then running back. I'm back on my normal prompt. And I could do the same thing on AWS. So if I switch to AWS, I can. This is a Docker container now running on a machine on AWS. It magically sets up all of the tunnel for me, and although it looks pretty much the same, as long as I've done it right. Yeah. No. What's a nice way? No, I can't think of a nice way to show you it's AWS. Anyway, so I'll go back to my prompt. And so even though I'm on a Mac, it allows me to run Docker images and containers on other machines. And it's all done through VirtualBox. So there's a VirtualBox image that effectively gets started up. This slide was written before today. So it used to be that they didn't have as good support for Windows, but their Windows support is getting much better. It's still not as good as Mac, but if you want to use Docker Toolbox on Windows, it's now not too bad. And one thing to note is that for some features, you use the file sharing that is provided by VirtualBox, and the performance of that is appalling. It's really bad. But there are workarounds for that. Yeah, so why Docker? I won't cover this here. Basically, we started using Docker purely to deploy multiple copies of the JVM on one machine, nicely isolated. That was the original reason for starting to look at it. I was 6 months ago, I was saying that it's a bit early to pick Docker, but it still seems to be the popular way of doing containerization at the moment. So if you're thinking about doing this for your deployments and your development, it's looking like a good choice. So some things when you're trying to Dockerize Sakai to running a Docker container. It's big. It's very big. Do you know what I mean? We're talking sort of 600 megabytes of Sakai, and that means that some of the normal patterns that you use when deploying an image don't work with Sakai or make development prohibitively slow. It also has a slightly complex deployment with its build processes and the way it starts up and the services that it needs. Yeah, I'll skip the JDM issues. That was one of the benefits that we got from Docker, was that we were always running on the same JVM. Because Sakai is tricky to start up, we really benefited locally from Docker because it's very easy to have an environment that anyone on their machine can just run, and they don't have to worry about following instruction guides. They basically install Docker, build a copy of Sakai, and then start up their Docker container, and it all just works. I realise I'm getting close to time. So it does have lots of issues that we've sort of run across. Some of them are security, some are things that you forget when you're just you effectively depend on as part of the distribution that are no longer set as part of a Docker environment. But it's very good at highlighting all that. Yeah. Oh no, how long have I got? Am I still? I've got about 5 minutes, haven't I? So a Docker container is just one process running, and it's not often that useful to just have one process. So if you want to manage multiple processes or multiple containers at the same time, there's something called DrCompose. And so we use this to start up a copy of Sakai and a copy of MySQL at the same time. So let's go and see if I can show you this in action. So inside, So here we have a set of Docker files and a few Sakai files. Inside the Tomcat folder, I've deployed a copy of Sakai, and there's this DrCompose command, and it allows you to see the multiple containers that make up this image. So here we go. Let's leave. As always, it fails. Yeah. Okay, so this will start up a copy of Sakai inside a Docker container and start up a copy of MySQL, and it will point the copy of Sakai at the copy of MySQL. So this means that your developers don't have to worry about setting UTF-8 character encodings because your Docker image has it pre-set up. And as your deployments get more complex, it means you can pre-configure other things. So in our local deployment, we use Apache as a front end. And so our DrCompose setup allows a copy of Apache to also be started in front of the copy of Sakai. So there we go. So that's a copy of Sakai started up in 45 seconds and a MySQL database as well. And I could do the same thing of starting it on AWS. I'm sort of cheating. Well, I'm not cheating. There's some more complexities in about how we're managing the Docker setups here to aid development. But effectively, you can do the same thing and start up the same image on AWS by just running the DrCompose up, and it will download the images that are required and start it up on AWS. So DrCompose is just, it makes it really easy if you can get your developer to have the DrCompose files to just type DrCompose up. There's one thing I would say about Docker. If you're thinking about using it, it is a bit like Git in that it can do some really nice things, but it can go a bit scarily wrong and can need a bit of debugging. And it can get, if you're not all that experienced with Linux, can be a bit hairy. When it all works, it's lovely, but it doesn't always all work. I don't mean that it's not reproducible. I mean that sometimes you're trying to do something and you've changed some configs and you don't understand the build process correctly, and trying to debug those sorts of issues can be a little tricky. But when you get it to work, it does work very nicely. So other things, I've talked a bit about Docker Machine that allows you to set up machines running Docker, and they can be anywhere on VMware instances, AWS, Azure, or VirtualBox. And then there's Docker Swarm that allows you to more dynamically manage services running across multiple machines. I think I'm running out of time, so Mike asked a question earlier on about handling traffic scaling out for your Sakai instances. So we have multiple Docker containers running across multiple physical hardware, instances of physical hardware, and they all expose a port on the actual physical machine, and then we have a Citrix NetScaler doing the actual scale out for the traffic. So we don't do any dynamic traffic management at the moment. It's just because of the limitations of our Citrix setup. I will say though that Docker does make it nice and easy to spin up 2 copies of Sakai if you're ever wanting to test clustering, in that you can, in your DrCompose file, say I want 2 copies of the app server rather than 1, and it will start at 1 copy of the MySQL database and 2 copies of the app server. If you're happy to mess about with port numbers, then it will just randomly assign them on ports. But if you want to do a bit more work, then you can have something like those two app servers register with an Apache or an Nginx instance on the front end, and then actually have your load balancing Dockerized as well. And we're using all of this stuff actually in production now. The one thing I would say is the only thing that we are actually Dockerizing in production is our Sakai instances. We're running MySQL on native, or just on raw hardware, and we're running Solar and Apache and the Netscaler as raw hardware. But that's partly because our Docker is being done internally within the WebLearn team, and our hosting team isn't as keen on Docker. Okay, new stuff in Docker 1.9 and some links. And if you want to try running Docker or Sakai inside Docker, there is a GitHub project that has a copy of some Docker files and some DrCompose files that allows you to deploy a copy of Sakai using Docker. There is a README, but I think there's 2 steps missing from the instructions, which I'll try and fix. So yeah, any questions? I think I'm just running out of time.
Okay. Thanks, Matthew. I don't see any questions coming across the chat. I'll go ahead and stop the recording. Thanks, Matthew.
Okay, cool. Thanks, guys. Thanks, everyone, for coming. And I hope it was useful. If you've got any questions, just let me know.